Hello, and thank you for subscribing to Introverse Tech. This is a channel where we explore new trends and technologies. And today we are following up on our last tutorial on Python lists. And today we're going to cover Python tuples. Now, they're very similar to a list. However, the key differences are that it is a collection, ordered collection. It's immutable, so you can't change the items, but it allows duplicate values. And tuples are also used to store multiple items in a single variable, and we're going to see an example where we can give multiple values to a single variable. And tuples are typically written with round brackets, and they are indexed. So the first index, like a list, starts with a 0, the second item has index 1, and so on. What would be some use cases of tuple? Because remember, we said they are immutable, or they can be changed once we have created that tuple. So an example could be a calendar, or could be 4 seasons, or something that will remain the same, right? Those calendar will always have 12 months. The 4 seasons will always have 4 seasons. So some values that during programming or during access you don't want them to be changed, you can put them in a tuple. That's a brief introduction. So let's get started. As you can see, I have a Jupyter notebook running, and you can use any of the other IDEs or tools available like VS Code. I just find it for these kind of tutorials, I just find it easier to show them or demonstrate in a Jupyter notebook. Okay, so as I mentioned earlier, since they are immutable, so some of the functions like a remove or an append that we saw in list does not apply here. And I'll make sure to post that link to the Python lists tutorial so that you can reference that as well. So let's get started. I just want to show you a few tuples, and it shows that it can support different types of data formats. So you can have text, you can have numbers, you can have Boolean, and all of them are valid. You can also have a mix. So let me bring up another. I'm calling it mixed tuple, and you can see it contains the 3 data formats, including text, numbers, and Boolean. I can run that, and I can print that, and it runs, right? It shows those different texts. And you can also have duplicate values, as we mentioned in the introduction. So if I run this, you can see that it does accept multiple or duplicate values of one of the items as well. So it took 2 Mazda, and that's also acceptable. Now when we are accessing elements in a tuple, we have to know that if they are ordered. So the first one is at index 0, and then 1, and so on. Very similar to what we saw with lists. So if I was to look at the second index, so which is 0, 1, 2, so I should get master as an answer if I run that. So that's just the third item, because you start with 0, index 0. Similarly, I might need to look at the last item in that tuple, and usually one does not know the the size or which is the last element. So a shortcut is to use -1, which will give us the last element. So when I run that, you can see that I ran that on the mixed tuple, and you can see that the last item was false. Okay, we can also specify a range. So if I bring up the tuple that we created earlier, which is a mixed tuple, you can see that I can now print between a range index 2 to 5, and similar to less, we go the last minus 1, right? So when I run that, you see I start with 0, 1, 2. I start with master. I go all the way till 5 and 1 less than 5, so which is ending at 2. So we get these 3 elements from that range. You can check with different ranges and they should all work. If we leave out the first item in that range, similar to here, when we run this, what happens is that the range starts from the first item because we've omitted that here. So when we run that, you can see it started from index 0 because it was omitted here, and it goes all the way to index 4 minus 1, which is 0, 1, 2, 3, 4. So you should end up with these 4 values. Okay, let's look at some other examples. We can similarly start with an index range but leave out the end, right? In this case it will search to the end, so it will start with index 0, index 3 here, and go to the end of the range. So you can see here it started with 3 and it went all the way to the last item in that tuple. And we can also specify a negative index if we want to search from the as an example from the end of the of the tuple. So let's bring up an example. So we have the mixed tuple with all these 3 data formats, and we say print -4 to -1. So it will skip the last one because it starts with the last item and it goes all the way to -4. And when we run that, you see that it includes going back to -1, -2, -3 up to -4. That's included, and the last one is one more than that. So that's also a way to find any element starting from the end of the tuple. We can also use some commands to find where a certain element is. So in other words, we want to find the index of where an element is. So as an example, I have a fruits tuple. It's got some fruits there, and if we say okay, print where, it shows the index where this kiwi is. So when we run that, it tells it that's on index 3, which is correct. 0, 1, 2, 3. That's where the kiwi is. We can also sometimes want to find the length or the total number of elements. So we use length or len for short, very similar to list. And when we run that, we see that it says it's got 7 elements in this, or 7 items in the tuple, which is correct again. We can also use a max to find the maximum tuple. So when we run it on text, it's usually in order of the alphabetically. So when we run that, we get pineapple. If I run that on a number, it's easier to understand. You should get the highest number here. And I can also run a min, which is the minimum in this list and in this tuple, and you will see that I have a let me just add a 0 here and see how that behaves if I run that again. So it updates, and now the smallest number is a 0, as you can see from this list. We can also use something called a count to tell us how many items of a certain item exist in this tuple. So if I have a points tuple and I've got this range of numbers, we can say okay, count how many times 9 appears, and when we run that, it tells us that there are 4 instances of 9 in this list of tuple. We can update this to add some more, and when we run that again, it tells us the correct number. So 7 instances of 9 in this points tuple. Now we can also check for a certain tuple if we can match the text. So you have a cars tuple, you've got some car names. If you're saying if this text matches what is in the cars tuple, then you can say yes, print it out. So when we run that, it correctly says yes, Ford is in the cars tuple. We can replace this with another, let's say Volkswagen, and run that, and let's see what the result is. So it didn't print because we didn't have that. But if I was to replace that with, let's say, Toyota, then the print should execute and run. So we just need to change it here as well and rerun that, and it's correctly runs that. Now, since we mentioned the primary difference between tuple and a list are that tuples are unchangeable or immutable, that we cannot change, add or remove items once the tuple is created. However, there are some workarounds, and one of those workarounds include converting a tuple to a list, making the change and converting it back to tuple. So let's show that with an example. So I have a fruit tuple, it's got some fruits. We introduce a fruit underscore list, and we use the list command to convert that fruit tuple into a list. Then we make the changes that in index 1 replace it with kiwi. So right now index 1 is banana, so we're saying in that list change that to kiwi. And then we again use the tuple command to change the fruit list and assign it back to fruit tuple, and when we run that, we should expect this to change and kiwi to be inserted. So let's run that, and you can see that in index 1, which is index 0, index 1, index 2, it successfully changed. So this is a workaround. You had a tuple which is immutable, we change into a list, we make the change and we change it back. Similarly, append is not supported natively because again we cannot change, so we do the same workaround. In this case, we use the append, and we are adding kiwi, so typically it adds to the end, and again we convert the list, fruit underscore list, back into a tuple using the tuple command, and when we run this, you can see that it successfully added or appended a new fruit at the end of the tuple. So interesting a way or workaround to make that change. You can also join tuples. So here we have an example. We have tuple 1 with some values, tuple 2, and we can simply add them, and the resulting tuple 3 will have all of these values. It also supports what we can call like multiplying a tuple. So here we have a fruits tuple with some fruits, and you introduce a new variable called my tuple, and it just says whatever is the fruits underscore tuple, multiply that twice, and when we run that, we get basically a copy. So this is one copy and this is another copy. We can also use the same workaround that we looked at to actually remove. So remove by default is not supported because it's supposed to be immutable, but we can use that same workaround that we did for adding or appending, and use that workaround to make that changes. So we have a fruit underscore tuple, we convert that into a list, then we say we'll remove what matches apple, and then convert it back into a tuple. So when we run that, you can see it successfully removed apple because it matched to that, and you are left with 2. So we were successfully able to change that tuple. Now we can also have we can use the del or delete command. In this case, I'll just add a, and let's run this. So it didn't run anything, right? But it actually deleted the fruit underscore tuple. Now if I run this, it will give an error message because it doesn't exist, right? We already deleted it here. Now an interesting property of a tuple is what is called unpacking a tuple. So let me show that by an example. So we have a fruit underscore tuple with 3 items, and we define 3 variables: variable 1, variable 2, variable 3, and we're saying assign those to fruit underscore tuple. The items, assign them to var 1, variable 1, variable 2, and variable 3, and then print those out. When we do that, because we have the same number of items as the variables, they are assigned. So variable 1 gets apple, variable 2 gets banana, variable 3 gets cherry. So it's important to understand that the number of variables must match the number of values in the tuple. If not, then we have to use an asterisk to collect the remaining values as a list. And remember, in the introduction we said that a tuple can also be used to store multiple values in a single variable. So let me show that with an example, and let me just bring it here. So in this example, we have a fruit underscore tuple with 5 fruits. However, the variables we are defining are just 3. So we expect this to throw an error, and when we run that, it definitely shows an error because it says too many values to unpack. We expected 3 and we have way more than that. So how do we deal with this? One way to deal with this is to just add an asterisk in. Let's say we want variable 1 and variable 2 to collect the items, and the last variable to collect the remaining ones, right? So when we run this allows us to have apple assigned to variable 1, banana assigned to variable 2, and the rest of them, they could be many, they are all packed or put into variable 3. So this is an interesting way of how tuples work, that you can assign multiple variables, multiple items to a single variable. And I can just maybe switch it here and see what the effect is, and take it away from here, and let's see when we run that. So in this case, apple was assigned to variable 1 as expected, and then variable 2 got the rest, the 3 of them, and the last one was assigned to variable 3. So different ways to approach this, but the idea is that multiple tuples allow multiple items to be assigned to a single variable. Now we can also look at some using the for loop to loop through the items in a tuple. So we have a fruit underscore tuple. You can use x in fruit tuple and print that x. So this can be anything, and I can show you. So here I could say x2, as long as I say x2 here, so it really doesn't matter, it can be anything, and it just goes through and prints out all the items in that tuple. We can also use the length command to go through each of these, step through all the items. So in this case, it uses the for I in range, and here it's calculating using the length to find out the total amount of items in that tuple, and then uses that to run through all of the items in the list. So as we do that, let's say we increase this to 4. So when we run this length on this, it will actually give you 4. So then it should print 4 items. When we run that, you get 4 items, right? Because it's able to, length is able to give out the total number of items, and then for loop steps through all of them. And similarly we can also use a while command, and in this case the only difference is when we use while, we initialize the iterator to 0, and we say okay, while I is less than the length of this tuple, again we use the len, and then we just print it. This indicates the index, so it steps through 0 all the way to the length -1, and then once we print it, we want to point to the next item in that list, and so on. When we run this, it successfully prints that. Let me add this here and see how that behaves. It should have exactly the same behavior, because all we're doing is just stepping through that using the while loop, and so it does that. So this was again a very basic and quick introduction to tuples. I hope you've enjoyed this, and like I said, I'll post the link to the previous tutorial that covered the introduction to Python lists, and I will be following up with additional tutorials on Python sets and Python dictionaries. So stay tuned. Thank you for watching.